Before we start solving questions based on areas in combination figures, that is circles and other polygons like squares and triangles and all, let me help you understand how you are supposed to approach these kind of questions. And it's very interesting. So for that, I'll start by asking a question. Take a square. From all the four corners here, take quarter circles like this. Shade the central region. Now the shaded region here, keep this in mind. Now take the same square here and cut the maximum circle out and shade the four corner regions. Shaded region in this diagram is same as the shaded region in the second diagram. So my question is why? So if you try answering this question, just take some time and try answering the question. There's a very interesting way where you can answer this question, and a very simple way. That is by here, how we got these four quarter circles. They were drawn with keeping these four corners as the center. Now, just make all four of them upside down. Just flip it over like this. When you just flip it over like this, we get a circle here, which is same as the second one. Now, can we actually flip all of them over? Is a question which you need to understand, right? So for that, take just one part of it outside. So initially, the quarter circle was like this from this corner. Now, when I just flip it over, it is still a quarter circle with this corner as the center. So obviously, this shaded region will be equal to this shaded region because both of them are. What is the shaded region? One of the shaded region is nothing but from this square. If I take out the quarter circle, the remaining part is the shaded region. So whether I take out this quarter circle or this quarter circle, since they are exactly the same, I can actually flip it over, right? That's the reason. Now if I bring the original figures back, shaded region here in the first diagram, which is there in the central part, is same as the shaded regions in this particular diagram. You can also think this way, it's equivalent of all this. When you are flipping it over, what's actually happening is these shaded regions, maybe since I use these central lines, there are actually four of them. They are just pushed away from center to the corner, or from center to the corners 1, 2, 3, 4, so that we get the second diagram. So it's an interesting way to connect these two diagrams, right? What we are doing is we are simply flipping it over to get the second diagram. So I'm sure in an intuitive manner, all of you understood why the two shaded regions were exactly the same. Now you can compare this with, just to give you a scenario, assume that the same square field, if it's a square field, grass field, if the area which a cow can graze where with a rope of this length, if it's in this corner, it can cover this much. In this corner, it can cover this much. From this corner, it can cover this much. From this corner, it can cover this much. The one area which it cannot cover is the shaded region here. That is same as if you just keep the cow in the center, it can cover with just one rotation. It can cover this much area. The one area which it cannot cover is the shaded region. And these two are exactly the same. Why they are exactly the same? We understood in a very simple manner. Now, doing things like this will make a huge difference in the way you start solving or start approaching questions in complex diagrams or in combination diagrams. Nothing is complex. Once you start thinking, everything will become very simple and interesting.
If you like this video and want to watch many more amazing videos like these, like and subscribe to our channel now.